Okay, we're going to continue looking at graphs of quadratic functions, and especially look at quadratic functions in standard form. But first, let's just kind of do a quick review again of the information we know about a quadratic function graph. Okay, so remember, quadratic functions are of the form y equals ax squared plus bx plus c. And sometimes instead of y, we see f of x, so f of x equals ax squared plus bx plus c. And then, of course, a cannot equal 0, otherwise it won't be quadratic. So, for example, y equals x squared. This is our parent function. This is what our parent function graph looks like. Okay, of course, the shape is a parabola. Okay, this point here, which is the origin, is our vertex. It's also our minimum point. So the vertex is the minimum or maximum point of a quadratic function. Okay, this particular parabola opens upward. It looks like a U. And the y-axis in this case is the axis of symmetry. Remember, the axis of symmetry is an imaginary vertical line running through the vertex of a parabola. The left and right sides are symmetric. Okay, so y equals ax squared plus bx plus c, or f of x equals ax squared plus bx plus c. This is considered standard form of a quadratic function. We already saw vertex form. When a is greater than 0, this parabola opens up. When a is less than 0, the parabola opens down. The y-intercept, which is where it crosses the y-axis, is at the point 0, c. So whatever value is in the c position. The axis of symmetry will have the equation x equals the opposite of b over 2a, using b and a from the standard form of the quadratic function. And the vertex will be the opposite of b over 2a, so the same x value that we had for the axis of symmetry, and then f of the opposite of b over 2a. In other words, this is just a fancy way of writing the y value when you plug in the opposite of b over 2a for x. So for example, for this function, y equals x squared plus x minus 6, determine the vertex, the y-intercept, and the axis of symmetry. And then sketch its graph. So the y-intercept is the point 0c, so here it's 0, negative 6. The axis of symmetry is the equation, well, remember it's going to be x equals the opposite of b over 2a, but a in our equation is 1, b in our equation is also 1, and c we've already identified as the negative 6. So x equals opposite of 1 over 2 times 1, or x equals negative 1/2. The vertex then is negative 1/2, f of negative 1/2. So let's plug in negative 1/2 for x and get negative 1/2 squared plus negative 1/2 minus 6. You know, I like to continue using fractions. It's okay if you also put it into your calculator and use decimals. So here 1/4 minus 1/2 minus 6, which ends up being negative 25 over 4. So our vertex is negative 1/2, comma, negative 25 over 4. So let's sketch this. So first, plotting my y-intercept, which is 0, negative 6. Okay, here's my axis of symmetry, or x equals negative 1/2. So here's my vertex, which is negative 1/2, comma, negative 25/4. Now let's create a table to get some more values to continue looking at the shape of this graph. So just like when we had vertex form, I have my vertex first. But since we're starting with a fraction as an x value in the vertex, we're not just going to go 1 unit away, 1 unit less and 1 unit greater, 2 units less and 2 units greater. I'm going to first just choose the first integer less than negative 1/2, and then the first integer greater than. So 0 is the one that's greater than, and when I plug 0 in, I get negative 6, which we've already graphed. Okay, then negative 1, 1, and negative 2. So if I go next integer less than negative 1/2 is my negative 1. When I plug that into the equation, I get negative 6. And then from 0, what's one more unit greater than that? 1. So I'll choose x as 1. Plugging that in, I get negative 4. If you want to see it, 1 squared plus 1 minus 6, that gives me negative 4. And then 1 unit less than my negative 1 is negative 2. So negative 2 squared plus negative 2 minus 6 also gives me negative 4. So let's plot these other points. Okay, I have negative 1 comma negative 6, 1 comma negative 4, negative 2 comma negative 4. So sketching in, here's my parabola. Okay, using the information provided in the graph, write the equation of the quadratic function. And we're going to keep it in vertex form. So we're given a graph of a parabola that opens downward, has vertex 2, 3, and also contains the point 0, negative 1. So, since you have the vertex, we're going to start with vertex form. Our vertex form is y equals a parenthesis x minus h quantity squared plus k. And let's fill in h and k. So our h is 2, our k is 3. So we have y equals a parenthesis x minus 2 quantity squared plus 3. Okay, then we're going to use the second point to find a. So our second point that we're given is 0, negative 1. 0 is our x, negative 1 is our y. So negative 1 equals a parenthesis 0 minus 2 quantity squared plus 3. We plugged 0 in for x, and we plugged negative 1 in for y. Let's simplify this. So negative 1 equals 4a plus 3. Let's solve this equation. Bring the 3 over. Negative 4 equals 4a. Divide both sides by 4, and a is negative 1. And negative, it needs to be a negative because it opens downward. So this is a value for a that makes sense. So therefore, our equation is y equals negative 1, or just negative, x minus 2 quantity squared plus 3. Okay, this example is a little bit more complicated when we're using information in the graph and using 3 points in order to write the equation of a quadratic function in standard form. Okay, so here we've got a parabola, and we've got the 3 points identified. Negative 2, negative 9, 1, 6, and 3, negative 4. So since we don't know any of the intercepts or the vertex, we're going to start with standard form. Standard form of a parabola is y equals ax squared plus bx plus c. And we have these 3 points. It doesn't matter what order I write them in. 1 comma 6, negative 2 comma negative 9, 3 comma negative 4. Then we're going to substitute the 3 points into the standard form equation to generate a system of 3 equations. So the first time, I'm just putting 6 in for y and 1 in for x. So I get 6 equals a parenthesis 1 squared plus b times 1 plus c. Second one, I substitute in negative 2 for x and negative 9 for y. I get negative 9 equals a times negative 2 quantity squared plus b times negative 2 plus c. And the third one, y is negative 4, x is 3, so negative 4 equals a times 3 squared plus b times 3 plus c. So if I simplify these, the first equation is 6 equals a plus b plus c. The second equation is negative 9 equals 4a minus 2b plus 3c. And the third equation is negative 4 equals 9a plus 3b plus c. Okay, so we now have 3 equations with 3 variables. So we're going to solve using Polysimultaneous 2 app on the calculators. You can also solve this using what we did when we solved with matrices. We used the RREF command, and that will work here just as easily. But I thought I'd introduce a new app. So on the graphing calculator, so when you hit apps, you're going to find Polysimultaneous 2 and you're going to hit enter, enter. Then choose number 2, which is simultaneous equation solver. Then choose the settings shown here for 3 equations and 3 unknowns. So equations 3, unknowns 3. I'm going to leave it as fractions, but you could also have decimals. Everything else, it should be normal, float. Now I actually don't care whether it's radian or degree. Number 7, hit the graph button, which corresponds to the next screen, and enter the coefficients from the equations. So the screen looks like this. Okay, this looks like our augmented matrix that we could also put directly into a matrix. Okay, then you're going to hit the graph button in order to go to solve. So the final screen shows the solution. So x1 equals negative 2, x2 equals 3, x3 equals 5. A is negative 2, B is 3, C is 5. Substitute the values shown into the standard form equations. So our equation. So y equals ax squared plus bx plus c becomes y equals negative 2x squared plus 3x plus 5. So try this. So using the information provided in the graph, write the equation of the quadratic function and keep it in vertex form. So we have a graph that opens up, has vertex at negative 3, negative 4, and contains the point 0, 14. So pause while you try to write this equation, and then hit play again to check your answer. So y equals a times x minus h quantity squared plus k. -3 comma -4 is my h and my k, so y equals a times x plus 3 quantity squared minus 4. Then I'm going to use the point 0, 14. 14 equals a times 0 plus 3 quantity squared minus 4, or 14 equals 9a minus 4. 9a equals 18, or 8 equals 2. So our quadratic function is y equals 2 times the quantity x plus 3 quantity squared minus 4.